Okay, we're going to talk about 18G. There's just a couple things in this section that was not in the SL book. First of all, now that you know how to do implicit differentiation, which is something that the SL book didn't teach, you can also now derive the derivative of natural log. So the way you do that is you do implicit differentiation on an expression which is equivalent to y equals e to the x. We know how to take the derivative of y equals e to the x. Now we want to take the derivative of y equals natural log of x, which we already know from the functions chapter that is the inverse function of y equals e to the x, right? They do two opposite things. What we're going to do is we're going to rewrite the inverse function so that it is in exponential form. So, like, remember when you do variable interchange, right after you do variable interchange, that is the exponential form of y equals natural log of x, right? So y equals natural log of x, remember, is the same thing as e to the y equals x, right? How do you find that? You could take e to the whatever for both sides. E to the y equals e to the natural log of x. E to the natural log cancel out. You get e to the y equals x, right? So x equals e to the y is an equivalent expression to y equals natural log of x. We can do implicit differentiation on this expression, and we can eventually find the derivative of the natural log function. Okay, so let's take the derivative of both sides here. Derivative of x with respect to x is 1. The derivative of e to the y is e to the y dy dx. Now, what is dy dx? Remember y equals, what y equals is natural log of x. What is dy dx? What is the derivative of natural log of x? Well, it's equal to 1 over e to the y. What is that in terms of x? Well, remember, y equals natural log of x. I could put that in here. I'll get 1 over e to the natural log of x. Well, e to the natural log of x, you can cancel out e to the natural log because they undo each other, and you just end up with 1 over x. Hey, what do you know? The derivative of the function y is 1 over x. So the derivative of natural log of x is 1 over x. So now that we know that the derivative of natural log of x is 1 over x, we can do problems where we have y equals natural log of x, take the derivative of it. What about slightly harder ones where we have a different log base? So like here we have log base 3, or log base 2, here we have log base 3. How do you do those? Okay. I think the easiest way is to use the change of base formula, which is on your formula sheet. Remember that the log of base A of B is equal to the log base C of B divided by the log base C of A. So what you can do here is you could say, I want to put everything in terms of natural log. So you could say log base A of B is the same thing as natural log of B divided by the natural log of A. Okay? So like for this case here, I have natural log, or I have log base 2 of x. That is equal to natural log of x divided by natural log of 2, right? And remember, natural log of 2 is just a number, so that's like a coefficient. So if we want to take the derivative of this, we could say, okay, natural log of 2 just stays there because it's a coefficient. Derivative of natural log of x is 1 over x. So basically we have 1 over x times 1 over natural log of 2. Okay? Okay, C is slightly more complicated because on this one we have base 3, and we also have a product rule going on here because we multiply by x, which is a variable expression also. So if x is u and log base 3 of x is v, then we do the product rule on this. So this is equal to, first of all, let's rewrite this so that it uses the change of base rule. So x times natural log of x divided by natural log of 3 using this change of base rule, right? Okay, now let's take the derivative. Let's take the derivative. So if we take the derivative of this, we're going to have the natural log of 3 just stays there on the bottom. And on the top, we're going to have u, which is x, times natural log of x derivative, which is 1 over x, plus u dash, which is 1, times v dash, which is, v, which is natural log of x. So basically we got x times 1 over x, which is just 1, plus natural log of x divided by natural log of 3. Okay? In the back of the book, they rewrite natural log of x divided by natural log of 3 as log base 3 of x, but you don't need to do that. Okay? Number 7, find DADB if e to the blah, 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 blah equals 21. Okay. Looks like we're going to have to take an implicit derivative here. Let's try it out, okay? So we're taking the derivative with respect to b. Okay, so we're going to take a derivative with respect to b of everything. Okay, so here we go. So this first term is actually a product of two variable expressions. So we're going to write down u, e to the 2a, and then we're going to take the derivative of v, which would be, let's see, the derivative of natural log is 1 over x, so it would be 1 over b squared. Take the chain rule of b squared, which would be 2b. We're taking with respect to b, right? Then we need to do u dash v, so u dash would be e to the 2a times 2, and then dAdv, because it's with respect to b, not to a. And then we multiply times v, which is natural log of b squared. Okay? Let's take this next expression, a cubed b. Now, a cubed b is also a product, so we need to first write down u, which is a cubed, and then we need to do v dashed, which would be the derivative of b. Derivative of b with respect to b is just 1, so we don't write down anything. And then we do plus, and then we take the derivative of a cubed, which would be 3a squared dAdv, because it's with respect to b, not with a. And then we multiply it times the other multiplier v, which is b. Okay? Then I put everything with a negative sign around it because there's a negative sign here. Then we're going to take the derivative of natural log of ab. So natural log of something, derivative is 1 over something, so 1 over something is 1 over ab. Then we need to do the chain rule. We need to take the derivative of ab, which is a product of two variable expressions. So it would be u, which is a, times v dashed, which is just 1 because the derivative of b with respect to b is 1, plus the derivative of u, which is dAdv, and then we multiply it times v, which is b. Okay, so there we have that. Last of all, we take the derivative of 21, which is this 0, right? Next thing I'm going to do, I'm just going to simplify some of these expressions. So like, for example, this expression here, I'm going to multiply everything together. I end up with 2 e to the 2a divided by just b, because the b squared cancels out with the b and leaves just 1b on the bottom. This one here, I put the 2 out front. This goes second. Then I put natural log of b squared third, and then I put dAdb, which I abbreviate as a dash here. And then I put minus a cubed. I distribute the negative sign, and then this would be minus 3a squared b times a dash. Okay. Then this expression here, I'm going to distribute 1 over ab with the a and with this, so that would be 1 over b. And then a dashed divided by a, because the ab cancels out with the b, just leaves a on the bottom, and dAdb I abbreviate as a dashed. Okay. Then I'm going to take all the pink ones, which have dAdb in them. I'm going to leave them on the left. Everything else I'm going to move to the right. I end up with this. And then I factor out the dAdb from these three expressions. So I'm left with 2 e to the 2a natural log of b squared minus 3a squared b plus 1 over a times dAdb. And on the right side, I have this move to the right, minus sign. I have this move to the right, positive sign. And then this moved to the right, minus sign. So now I'm just going to divide both sides by this expression here, and then I'm going to have dAdB on the left, and then I'm going to have this divided by this on the right. And you can see that here. It looks like that. Now, the answer in the back of the book is a little bit different because they multiplied, I think they didn't want to have fractions within fractions, so they multiplied both the top and the bottom by AB and AB. And that got rid of the A's and the B's in the denominator. And the other thing they did was they took natural log of B squared and they rewrote it as 2 natural log of B, so there's a 4 here. But otherwise it's the same. Okay? Okay, 18H, derivatives of trig functions. Okay, so in 18H, you've already done the derivatives of sine, cosine, tangent. Now, in the HL book, they also go through the derivatives of cosecant, secant, and cotangent. And remember that cosecant is basically 1 over sine, secant is 1 over cosine, and cotangent is 1 over tangent. You know how to take the derivative of sine, cosine, tangent. So actually, if you are going to take the derivative of cosecant, which is 1 over sine, basically what you're going to do is you're going to just do chain rule and power rule. So let's try that, okay? So let's start with, okay, we're going to start with 1 over sine x, and then we're going to take the derivative of it. So basically, 1 over sine x is 1 over x, like it'd be u to the negative 1, right? Something to the negative 1. So we could just take the derivative of that by writing negative 1 times the something to the negative 2, right? And then we just need to take the chain rule, the inside, which is sine of x, so we'll multiply that times cosine of x. And that is equal to negative cosine x over sine of squared of x, which is equal to, I could rewrite that as, let's see, sine divided by cosine is tangent. So it's like having tangent on the bottom, right? And then it's also like having a extra sign on the bottom, right? So last of all, I need to put the negative sign on the top that was here, right? Okay, once I do that, sometimes you prefer to like have things written in the numerator, not the denominator. So I'm going to change tangent of x to be cotangent of x, right? Because that's the inverse of tangent. And I'm going to put cosecant x in for sine of x in the denominator because cosecant is the inverse of sine. Okay, so negative cotangent x times cosecant x, that is the derivative of cosecant. So that worked out, right? Now let's fill in the rest of these. Oh, sorry, I put the negative here, right? So don't forget the negative. For secant, the derivative is similar to that. It's negative secant tangent. Oh, it's not, I'm sorry. Positive secant tangent. Okay? Finally, the derivative of cotangent is negative cosecant squared. Okay, so like remember that the derivative of tangent I think was secant squared, so they kind of like have a symmetry going here, right? All right, let's do 6a. Find the derivative for x times secant x. So remember, I'm taking the derivative of a product, so basically I'm going to call this u and this v. So first I'm going to write down u, and then I'm going to write down v dash. V dash would be the derivative of secant is secant tangent, right? So I'm going to put secant x tangent x. And I'm going to add that to u dash, which is 1, times v, which is secant x. So there's my derivative of x secant x. Now let's take the derivative of 4 secant 2x. So 4 is just a coefficient. You can just leave it there. The derivative of the secant function, secant of something, is going to be secant tangent, right? It's going to be secant of the something times tangent of the something. And then we do chain rule of the inside function, which is 2x, so the chain rule would yield 2, right? So the answer would be 8 secant 2x times tangent of 2x. Okay, finally let's do the derivative of x squared cosecant x. So u is x squared and v is cosecant. So we're going to multiply x squared times the derivative of v, which would be the derivative of cosecant. Derivative of cosecant would be negative cosecant x times cotangent of x plus the derivative of u, which is 2x, times cosecant x. Okay. In the book's answer, they factored out cosecant and x and then left the remaining terms inside, but you don't have to do that. G, take the derivative of natural log of secant x. So the derivative of natural log of something would be 1 over the something. And then we take the chain rule of the something. So the chain rule of secant would be secant x tangent x. And so do you see how the secants cancel out? So what we're left with is tangent of x. Pretty weird. Okay, last one. We're going to take the derivative of cotangent of x divided by square root of x. That is a quotient, right? So u and v. So we'll say that, let's see, v squared would be the denominator squared. So square root of x squared is just x, so the bottom would be x. Then we would put square root of x here, and then we would find the derivative of u. Derivative of cotangent is negative cosecant squared x, right? Minus u dash, which would be 1/2 x to the negative 1/2. I'm sorry, that's v dash, right? Times u, which would be cotangent of x. And this was adjusted in the book solution, but this is okay.